Hello everyone, welcome to my channel Enthusiasm. This video is day 4 of the 30-day challenge. It is all about integration by parts. Let's check it out. Integrate e to the power of x times sine x dx. For these two terms, let's absorb one of them into the differential. Because e to the power of x is exponential function e, sine x is trigonometric function t. By the last rule, t is in front of e. So t is u and e is dv. In other words, we have to absorb e to the power of x, that is to integrate it. Therefore, the differential is d bracket e to the power of x. If you want to know more about the details of the last rule and absorption method, you may want to check out this video. The link is in the description below. Now, we compare it with the formula of integration by parts. U is equal to sine x and v is equal to e to the power of x. Therefore, the first term is the product e to the power of x times sine x. For the second term, we swap the functions sine x and e to the power of x. So the integral is integrate e to the power of x d bracket sine x. Let's look at the differential d bracket sine x. Because d sine x dx is equal to cosine x, so the bracket sine x is equal to cosine x dx. Put this back into the integral, it becomes integrate e to the power of x times cosine x dx. Well, the integrand is still a product of two functions t and e. Let's absorb e to the power of x again into the differential. So it is equal to integrate cosine x d bracket e to the power of x. Then we use integration by part for the second time. The first term is the product e to the power of x times cosine x. While for the second term, we swap cosine x and e to the power of x in the integral. Here, be careful about the sign. We have two negative signs, giving a positive sign. For this term, we differentiate cosine x to get negative sine x. Don't miss the differential dx at the back. Let's take a closer look to this equation. This integral on the right-hand side is exactly the same as the original one. We're just looping around. But don't worry, we can put this to the left-hand side of the equation. Then we get 2 times this integral. On the right-hand side, we take out the common factor e to the power of x to get bracket sine x minus cosine x. More importantly, there's no more integral sign, but with extra constant c only on the right-hand side. So to solve the problem, we divide both sides by 2. Then the answer for this integral is equal to e to the power of x over 2 times bracket sine x minus cosine x plus c prime. We use c prime to denote another constant. You may also keep it as c over 2. It is a really special case for integration by parts. We have to apply it twice to get the answer. Do we have other similar situations? Let's check it out in the video on day 5.